All right, why don't we go ahead and get started to accommodate all of your busy schedules, and additional members can join as they come. So you all have joined an ongoing series of member webinars that we've titled Leaders in Cognitive, because we'll be giving you the opportunity to listen to some of the most thoughtful and active executives and technologists practicing in the field today. We encourage all of you to interact with us at the end and the guest speakers as an integral part of this webinar format. We'll be kicking off the program with an introduction of Wayne and his work from Hadley Reynolds, who is co-founder of the consortium. Then we'll have the opportunity to hear Wayne share his fresh perspectives on the current state of AI, as well as how SAS is using a variety of learning technologies with customers, the tools they're choosing to work with, and how these approaches work out in the real world. We expect the conversation to run about 30 minutes, and then we'll open up the program to your questions. If you have a question, you can type it into the question box at the bottom of your control panel, or you can use the raise your hand function in the top left area of your control panel, and I'll unmute your line to allow you to speak your comments, and I will take the questions in the order that they appear at the end of the program. At this point, I'm going to turn the session over to Hadley Reynolds, who will get us started with the conversation.
Thanks, Hannah. Today, we're very pleased to have the chance to introduce you to analytics industry veteran Wayne Thompson. For those of you who don't know Wayne, he is the chief data scientist at SAS Institute, and it's very generous of him to break into what I know is a very busy schedule to spend some time with us. In addition to his day job taking care of multiple issues in advanced analytics at SAS, Wayne also blogs frequently and insightfully at the SAS Leadership blog stream on SAS.com. We posted a link to one of his recent pieces a few days ago on the consortium blog. In that piece, Wayne shares his perspective on the usefulness and the challenges of various algorithmic tools for analytics. He takes a particular focus on the practical value of deep learning and the ways Wayne has found to compare that algorithm family to a Swiss Army knife. It's a quick, fun, and insightful read. Wayne has been engaged in analytics development at SAS for over 2 decades. His focus has encompassed modeling and analytics on structured data in many forms and applications, and he has also been one of the leaders at SAS in the development of analytics for unstructured data types. He was instrumental in integrating the world-class portfolio of unstructured data analysis capabilities from SAS's acquisition of Teragram into the mainstream SAS product line. In addition to working with some of the world's biggest organizations on fast-forwarding their analytics practices, Wayne has for years been a tireless champion for removing the barriers to insight created by analytics tools that are difficult to use and hard for decision makers to understand. He is working to make SAS data mining tools and cognitive computing toolkits easy to operate for business users and analysts. A new generation of user interfaces to the SAS analytics platform is one of the results of his work in this area. I'm sure he'll touch on some of these initiatives today. So without taking up any more of the time Wayne has to share with us, I'll let him fill us in on what he'll be talking about over the next part of the session. Thanks, Wayne.
Well, thank you, Hadley. I really enjoy working with both you and Sue Feldman and Hannah. Sue has given some really awesome presentations at some of our events, and you know, I'm just delighted to be here, and we're going to have some fun with this. My presentation style is a bit informal, and I also like to show a little product because I'm a data scientist and I do have, you know, a background in analytics, but what I really enjoy is building data products. And I want to start with, you know, just this topic of artificial intelligence. I think it's definitely a revolution, but to SAS it is truly an evolution. And I'm really surprised, but you know, people seem to be settling in on what artificial intelligence is, and I've seen that happen over the last 6 months. There, I think, was a lot more confusion, even, you know, like I just mentioned, 6 months ago. And most of the people see it as, you know, the computer interacting with the human and doing tasks that we perhaps would do on ourselves. And at SAS, this is our official definition. And what I'd like to do is, we only have 30 minutes. I got quite a few things, but I want to kind of take you through how I've seen the artificial intelligence evolve, And I'd like to talk to you about also how SAS customers development partners and customers are using artificial intelligence, both for things like computer vision and also for what I consider to be cognitive services. Now, I am really big on connectionists. I think of them as, pioneers, first of all, in artificial intelligence. And I don't want to pigeonhole artificial intelligence as just neural networks, because we know that's not true. It includes, the whole field of natural language processing. But, back in the 50s, they developed these perceptrons. And we've all heard and talked about, kind of mimicking neurons and being able to fire and make decisions. But there was a primary issue with these things. They were slow, and they didn't really detect nonlinear relationships. And so the connectionists kind of died. And there was a lot of hype and a lot of promise, but that ability to really get in and solve nonlinear problems was an issue. And most of my career has been spent towards machine learning. And I see machine learning as a subset of artificial intelligence, and it borrows from a lot of other areas like statistics. I mean, we get maximum likelihood from statistics. We also borrow like simulated annealing from physics, but for the most part, I think a lot of artificial intelligence came from machine learning. A lot of machine learning derived out of artificial intelligence. And then I like to separate what I've seen in the industry, classical machine learning using techniques like regression, either logistic or ordinary least squares, and simple things like decision trees and so forth, even support vector machines. But over time, what I've found is really machine learning is more around automation and the ability to derive insights from data and do that fairly automatically. And now what I really see is, in many ways, data scientists have become almost arborists, if you would. Rather than, for example, build one decision tree, as I've depicted up above, which is, again, a heuristic type rule system that derives the underlying if-then-else structure of your data to create these homogeneous nodes, if you would, that you can use for decision making. But, I kind of see it almost like, it's probably a bad joke, but kind of like the Dos Equis man. I don't build one decision tree. We build thousands of them now, and we ensemble them. And we see this at Kaggle competitions and so forth through things like model stacking and even hyperparameter tuning, where we can automate a lot of the machine learning process. But I have really been, totally reinvigorated with deep learning. When Hinton came out, in Toronto around 2002, I do think deep learning is a Swiss Army knife. I do not think it is a fad. I do not think it is the end of algorithmic development, but these things are just so powerful. And as we would understand, they're just simply much more complex neural networks. And I like to say, take that, all of you doubters, because neural networks are definitely back. And the reason why they've come into vogue is, first of all, we can fit these very complex, multi-layer neural networks very efficiently today on very large distributed processing computers, even like GPUs. And we also have to have a lot of data. And even when they did backpropagation and neural networks in the 80s could do things like detect nonlinear relationships, they were still too slow. And we really didn't have enough data for them to continually learn. But these neural networks today, these deep nets, are very, very powerful classifiers, and they're fairly automated. They take the underlying features, which are the predictors or the inputs that you feed into the network, and they automatically, do feature mapping for you. So you don't have to, create all these transformations and all the secret sauce that data scientists do. There still is some work, but they're fairly automated. And the other aspect, too, is they are simply address a lot of applications, not only classification and prediction, unsupervised learning, but they're the best thing going for computer vision. We know that from the ImageNet portfolio and competition that's held each year that convolutional neural networks have just smoked support vector machines and other methods like principal components that were around for a long time. And, they are now able to detect, images better than the human eye. And that's very promising. These deep learning networks are also heavily used for speech to text. That's driving, for example, your speech to text on these mobile devices. And then when you couple them with natural language processing, I like to go all the way back to the 50s and go over there and get some things like natural language processing and combine that with deep learning and some of the traditional machine learning. We could put those together to make wonderful cognitive computing applications. And I think of cognitive computing as more the application side of artificial intelligence. And I see people, get a little bit, if you would, puzzled by all these terms because they are so related. But my recommendation is relax. All of these things are used, and there is some overlap. At SAS, I'm seeing, a lot of things happening from customers. As I mentioned, Hadley mentioned in my bio, I do think that a lot of people think analytics is too hard. And I think, by being able to embed things like natural language interaction and do voice commands and not only run a query, but apply analytics to derive insights from your data is the future. I think really BI is going to evolve into embedding artificial intelligence in it so that everyday knowledge workers can get insights. And that's something I'm definitely actively working on. And we're seeing a lot of work in the biomedical image area. At SAS, we're able to read, for example, DICOM formats off of, things like CAT scans and so forth, and we're able to understand, diseases better through biomedical image processing. And then chatbots rule. I mean, every organization that I talk to, whether it's a financial service company that wants to do call center escalation. I even have some that want to have financial assistance, to these personal coaches, etc. I think that that's another hot area. But this is kind of a laundry list of things that I've heard from customers, and I want to talk to you about some specific things that we're doing. And in fact, this customer was here all this week. This is Sci Sports. It stands for Scientific Sports. And think about them as being kind of the next Moneyball, like Bill James did with the Oakland A's. They want to apply computer vision, specifically models like YOLO, you only look once, for player identification and also team identification. And then what they want to do is they want to track, in real time, and they actually put cameras in all these stadiums, 14 of them, and they kind of replay the entire game in 3D, and they provide really performance assessment statistics about the players to do rankings. And these are provided not only to the football clubs throughout Europe and the world, but they're also provided to agents, and some of this information is also used in betting, gambling. So this is a real exciting area where we have partnered with these folks to really build out our convolutional networks, specifically for object detection and so forth, and the ability to deploy that in our event stream processing engine to make decisions in real time is really cool. By the way, this is the kinds of things. I'm not going to talk about SaaS products. I'm not here to try to sell you anything. I want to collaborate with the consortium. That's why we're all part of this wonderful, consortium that Hadley and Sue have put together. But from my perspective, we've got a cornucopia of machine learning. I'm just not going to go through and list out all of that because I only have like 15 more minutes to do my discussion. But we're providing not only the convolutional networks to do image analysis, but we're doing things like recurrent networks, which are very good at sequence analysis and eventually will be used in all of our text mining portfolio. And we're going to use that to write speech to text. These things are also very powerful as forecasting techniques. And then, our vision is to really allow you to interact with the computer. That means the computer needs to understand what you type or what you say into it, and we're going to use natural language interaction, where that takes your voice commands. It's not just speech to text, but again, maps it to analytics to automatically derive some insights. And then the other aspect is we want to understand on input through NLI, but at the back end, we want to explain on output through the machine. So we want to do narrative summaries. We want to use natural language generation, not just templated NLG, but data-driven NLG, to help summarize and provide information back to the user and then foster that interaction, which is truly kind of the holy grail. And to do all of this, we have to have a very open and scalable platform. SAS will ship on GPUs to do the training for these deep networks because they have thousands and thousands of parameters. And, we also have to make this accessible in a lot of different languages because data scientists may want to use a language like CASL, which is kind of a SAS code-based language. But, they may want to use something like Python or R, and you can actually call or write Python or R to execute the deep learning and the, natural language processing algorithms from SAS out on a SAS distributed server, and just result sets are returned back to the Python or R client. And then, of course, we need to make sure that computer scientists can build applications. Hadley, you and I know that SAS or Azure or any of these vendors are never going to make every possible application out of the box for these customers. So we've got to have a way for them to build applications using REST APIs and Java. So I hope you're having way more fun than you ever expected. What I'd like to do is just walk through a very simple example. And it's an example that I'm going to show using some code and actually what we consider to be our Python SAS kernel to SAS VIA. And again, this is called SWAT, where you actually take, as I mentioned, VIA is SAS. That's where we have SAS. And what you're able to do is these are all the clients and all the computation for these various packages that you use, let's say through a Jupyter notebook, are sent over to the SAS VIA server. We do all the heavy lifting, all the work here in a distributed fashion, and we bring the result sets back to the client. And this application is kind of cool because this one is, we have this organization that's trying to track these endangered species. We once thought there were like 3,400 tigers in India, and based upon some of the research here through this tracking protocol, there's actually only about 1,400. It's amazing, but unfortunately there are more tigers in zoos than there are in the wild. And they're looking at all kinds of endangered species, but before what they had to do is they had to, take the footprint, and then they would actually take these measurements and do this very manually to do, identification of the animal, not only from a species perhaps standpoint, but how the animal is migrating and moving. And some of this is to help prevent human and animal conflict. But with deep learning, what we can do is we can take these images and, as I said, automatically derive this feature map, and save all that time and all these measurements and so forth, and let the machine do the work for you. And this is really detailed and gory, but, I'm going to actually load and start my session here. And then I simply apply action sets to do things like load in the images. So here's an example where I actually load in some of the images. And I do that so I have training data and I have validation data. And the reason I have validation data is I want to make sure my model doesn't overfit. That's a very dangerous thing with these deep learning models, by the way. They can definitely overfit your data. And then they don't generalize well when you put it out in the wild, literally. That is, apply it to the entire population on unseen data. And this is a simple example where I'm simply trying to look at the difference between cheetahs and leopards. and the footprints that we've gotten from them. And to do this, you have to have pre-classified data. So these scientists have provided us already with images and labels, and that's a supervised scenario where the deep learning can then figure that out. And you do some things like, you pre-process the images, maybe standardize them to a size of 256 by 256. And you can see I've got 256 cheetahs, 299 leopards, and I have 558 non-footprints. Okay, these are not animal footprints at all. They're just images that do not represent a footprint of the ground, and the machine needs to tell the difference between that. And then there's all different types of convolutional networks. As I mentioned, SciSports wants to use a YOLO network to do object detection. Here we're using something called a VGG16 network to do image classification. This is a very popular standard image. And you simply define your network, your model, okay? And this is a very large model that has 16 hidden layers. And then we simply, once we've built that and defined that network, we simply train the model. And train the model is apply it to historical data and then use the validation data to retreat to a simpler fit to prevent overfitting. And you can see that this tells us what our network structure is. And there's something very popular in the literature too where you do transfer learning. And I think that that's going to be very popular because you can build these networks and get these initial weights and then update them. And that's incremental or progressive learning. So that's another benefit of these deep learning algorithms, is that they can continue to learn as you feed it more data. And you can also package these things up. Like if I was going to build an autonomous car and start that at let's say one of the car makers, I wouldn't start from scratch. I would go out and get models that were already developed to do that and use those models as kind of my initial seed. A couple more things here, and then I want to switch back to the slides. But I trained my network, and then at that point, I'm just going to go down to the bottom and show you how well we did. By the way, this model, if you can see, these are very big models. This has actually 165 million parameters. Okay, now a parameter is a weight in a neural network, and you can think about like a regression model or a regression coefficient. Well, these things, that's part of the secret sauce, is that they are progressive learners and they derive out all that insight. But after we've gone through and fit our model, essentially, I want to get down here to the point to where we have our model and the misclassification rate. And bear with me just a moment. This shows you how the model is continuing to fit across different holdout samples. And then I can score my model, but you can see that my overall misclassification rate was 16%. And that's not bad for taking, these footprints of these animals. We hope to get that down to around 6%. But again, by being able to classify these animals, we don't have to use evasive type procedures to track them and so forth. So that's a quick demonstration. And what I want to do is say, we also are putting together a very nice deep learning toolkit to allow you to work with these things and be able to build your models and then deploy them not only in batch, but deploy them into real-time applications, like I mentioned, as the football game is being played, let's say, in the Chelsea Stadium. Another thing that we're doing, I've already mentioned the DICOM format, and with the DICOM format, we're able to look at all of these different types of images, and we're not trying to replace physicians. We're not trying to replace those scientists out there in the wild. What we're trying to do is, through AI, we're trying to really help augment their profession and help them make better decisions through automation. And, if that thing can understand that you've got this, cancer and this lymph node in your lungs, really, from a second opinion, looking at the machine and so forth, it may not be actually cancerous. And maybe that's something that then the physician could do some additional work, because, that's obviously a very vital situation. And at the pillar of what we're trying to evolve, I haven't talked enough about the natural language understanding and natural language processing, But at the pillar of that, we can do so many things. We can do better prediction, better classification. We can do unsupervised learning to do things like pattern recognition and group, let's say, transactions together and understand which ones perhaps are fraudulent money transfers and are not, as a simple example. And, I would like to come back maybe and do another session when I have more time, but I would like to show you a little bit about how we're able to, do a conversation, really conversational analytics with the machine to help drive insights, and then put some narrative summaries around that. We also try to eat our own cooking at SAS. So this is an example where we have our solar farm, and we buy and sell energy from Duke Power, Duke Energy. And what we have to do is we really have to do effective load balancing. And even your energy company probably sends you information about, how to better utilize energy and what your trend looks like relative to you and your neighborhood. Duke surely does that for me. And again, we were using a lot of traditional forecasting techniques, but these recurrent networks, which are another type where they look at these short and long-term variability patterns in time series data, we simply got much better forecasts. And I think that we will see that also applied to things like the stock market. We will see that applied to a plethora of IoT applications where you're trying to forecast demand off of some type of sensor or equipment. And recurrent networks are definitely going to set the world apart. They're also very good, as I mentioned, for text analytics, and I'll hold that thought for another time. And here's another company where we're actually using a special type of convolutional network to detect defects in computer chip manufacturing in these wafers. And this is probably the largest semiconductor in the world. And they are applying these residual nets. It's a special type of convolutional network that actually uses the residuals, the output from predecessor layers. And they're looking at 8 or 9 different types of defects. And these things are just more precise than typical quality control measures that they were using before. And they are helping us build out these deep learning models, just like SciSports did with the football. So I'm going to skip the demo for natural language processing, and I just really want to conclude that we're all in on AI at SAS. Our goal is not just to really make an AI product. I think that is too limiting. All SAS software, every damn bit of it, will have some element of AI embedded into it. When I open up an Excel spreadsheet and the data is presented to me, it ought to tell me something about the data. And that's what we plan to do with our products at SAS. When we touch the data, the machine should provide some assistance to us. And it should provide some automated insights. And then, it should understand what we're asking about the data. And that's our goal. And the other goal, of course, is to make sure that we really aspire to enable you, the consumer, to go out there and build your own AI applications, because we're not going to be able to do everything you saw on that laundry list across all those different industries. And so with that, with that, we're very excited. AI is definitely, we can call SAS an AI company. We have always been an AI company, and it is at the front of what Dr. Goodnight wants to do moving forward. And again, it's not revolutionary to us. It's just part of our heritage, and we will continue to do that. And with that, I also want to kind of challenge you, and in our discussion, ask you, well, what's your vision? And perhaps together with SAS, we can accomplish something. So Hadley, that's right at about 35 minutes. I'm going to turn it back to you and Hannah, and thanks for having me.
Thank you so much, Wayne, for your time. We do have a question from Sue, and Sue, I see you've raised your hand, so I'm going to go ahead and unmute you so you can speak your question. Go ahead.
I needed to unmute myself too.
Oh,
So, Wayne, this is a great presentation. And you and I have had a number of discussions about cognitive computing in the past several years. One of the things that we're starting to hear is alluded to in the first part of your presentation in terms of all the terminology that we see. Could you try to differentiate for us the difference between Internet of Things and cognitive computing?
Yeah, in fact, at SAS, I guess this is well known that we just established a whole new division at SAS to do the Internet of Things. And
Yeah.
that will have a dedicated VP and a dedicated R&D staff, a dedicated marketing staff, and a dedicated sales and enablement. So we're regularly meeting with the senior VPs here, and that is the #1 initiative that was decided to go after. I think it's a great question, Sue, and by the way, I hope you're doing well.
Thank you.
Yes, we think a lot about you, and again, let's chat a little later sometime after this event.
Love to.
I think that really AI is the enabler aspect. In order to take that much information and the system, and you want to understand also, you don't want to build something necessarily historically, as we've done in the past. The system needs to be evaluated at that state. And I think things like reinforcement learners, which require deep learning and then require a policy reward type system, will be embedded into the Internet of Things. I see AI as an enabler of the Internet of Things, and that's how I position it.
Thanks.
Yeah. And, I think that the things that we're hearing most at SAS are, the #1 thing, I was talking to the CEO of FedEx, and, they want to keep these planes in the air at all times. That's the old school mentality, and the old school mentality was, well, then we have to have enough parts around. And they had a lot of just things on reserve across many different sites, and that cost them a lot of money. And I think, preventive maintenance probably is one of the biggest areas that we can help. Even things like, drones and having images of the outside shell of the plane when it lands and looking for damage and things of that nature, optimization of routing, etc. That's a huge area. And I'm most bullish, also on the biomedical area, which is not related directly at all to the Internet of Things, but I'm excited that some of these things we've had trouble conquering in the past will have a better opportunity with AI.
Yeah, and I agree with you entirely, but I also think that mixing what's important about IoT with cognitive computing and various other technologies as they come along is probably the most promising thing we can do rather than trying to be purists. I'm guessing you agree with me.
Yeah, I don't even try to talk about soft and hard AI. I talk about pragmatic AI, and what can we do as a customer. And the biggest issue I still find is most people are data poor. They have a lot of data, but they don't have a lot of the data in the right form to address these questions. And the other thing with deep learning and computer vision and voice is now, you can look at video, you can look at images, you can already do a lot of the text and structured, but we've got to get our data ducks in a row.
That may be the hardest challenge that there is in this field.
Yeah. Hannah, I'll turn it back to you.
Yes, thank you, Sue. At this time, I think Hadley had a few questions as well.
Yeah, thanks a lot, Wayne. That was a terrific run through, and we'll definitely set up some other session where we can dive more deeply into that natural language area that you skipped over in the interest of time today. One thought that occurs to me as we were listening to you talk about SaaS's approach here is, we hear a lot from IBM in particular, but also Amazon and Google and Microsoft about AI capabilities, and in general, what they are delivering, so to speak, or making available are portfolios of APIs, so that you can sort of go in and pick one or pick two, or try to mix and match. Or so, how would you compare or maybe contrast SaaS's approach to that sort of open catalog type idea
that's a great question
that they're using?
Yeah, and just for your interest in the market, what I'm seeing, and this is true, I mean, I was talking to datascience.com, a company that delivers a data science platform, and many others. We're still seeing probably well over 3/4. I don't want to go much beyond that on premise, and that's still, the current predominant delivery model. There is no question the cloud is important. There is no question it is growing. And the reason that we built VIA and that system were to have, first of all, fault tolerancy, because if you're going to do computing on the cloud, you have to have very strong SLAs. Secondly, you have to have a very powerful in-memory system that can manage modeling and looking at data, more data than you can fit into memory, and spool it out to disk and lazily load it. You have to have an elastic environment to make sure that it's cost effective for you, because you're going to have multiple tenants sharing the same environment. You can't stand up one for each in every case. It's too expensive. We're doing cloud computing now, and this customer Size Sports is actually working with SaaS through an MASP license, managed as a service provider license. That's how they're working with us and accessing our software. I think that all of these algorithms that I talked about, we now developed them at what's called an action set level, and all of them have open REST endpoints. I agree with you, though, Hadley, that we need to take more of these things and put them into something like face detection, emotion detection, and make them available to do that, and that is in our roadmap.
Yeah, what is there must be a lot of application areas that could conceivably be attractive. Maybe you could talk a little bit about how that roadmap gets constructed, whether it's by sort of general market analysis or tends to be more sort of customer-centric, if you will.
Well, one, definitely customer-centric, but, at SaaS, we want to, I'm working, for example, in fraud now, and the growth of our fraud business is just going out, it's leaps and bounds. I don't want to give you a percentage, but it's well over 38% growth. And I'm developing a bot that can, because the problem is that to detect fraud, it's a cost-sensitive problem. And I'm developing a surveillance bot, because these intelligent agents, it's a needle in a haystack, so you get too many false positives, and that requires a lot of these companies like Wells Fargo or Bank of Montreal or HSBC, they're just hiring more and more of these intelligent agents to triage these things. And so through better machine learning, whether it's unsupervised or supervised, we're doing a lot of better job of isolating this rare event. And then we've applied NLG on the back of the bot to help explain and profile was this fraudulent or not, and why, so that it can explain to the investigator. And then if the investigator finds out, in the rare instance that the machine didn't get the answer right, then we can put that triaging effort back into the machine and do incremental learning and pick up that behavior so the next time it doesn't happen. Our customer intelligence suite, I would say the customer journey and reinforcement learners is probably one of the biggest opportunities that we have. Just like you play the game of chess, you have a objective, and that is to take over and checkmate the king. And you're going to move your pieces, and it's a policy reward type activity. And you want to move them forward in the best possible way to maximize that reward. And you're willing to sacrifice things too, like pieces. The same thing happens in the customer journey, and we'll be applying reinforcement learners in that area. The big thing for SaaS is, again, we want to put this in these products, and those are just two examples.
Well, I'm certainly getting a whole lot of questions in mind, so maybe I'll do one more, or one more sort of specifically neural network related question, and then maybe a wrap up one. I wanted to ask you about explainable algorithms. That is to say, there's been a lot of discussion about how, because of the complexity of the multi-layered neural nets of various kinds, it's difficult for analysts or decision makers to understand exactly how the program came up with its recommendation, so to speak, or its answer. So what is your sense? And we understand that DARPA has a explainable AI type project going on, which would hopefully channel some energy into helping out with the transparency of these things. But I'm wondering what your thoughts are about that, and if there's any activity specifically at SAS about that.
And that's a very good point. I don't know if you can vision this. I could put up an image, but I don't have it handy at my desktop. Think about that 16-layer network, and if it's doing face detection, these are subcomponent modelers. So they like take a piece of your chin and piece of your nose and a tip of your ear, and subcomponents, all these pieces, patches of the image, and then through convolution and pooling, it tries to understand these very specific relationships which you cannot see, you cannot visualize, and they are a bit of a black box. So we're looking at model agnostic approaches. Once we fit the model using something like a deep learning model, then we apply another model to the result sets to look at, well, what variables drove those predicted values. So it's a model agnostic approach, and we're also trying to, for example, with that surveillance bot, is build a scorecard out of the model. And that way, because you have to provide reason codes and so forth for, these governed areas like financial services. The other thing that we're doing is, all these weights, we're taking and hotspotting them. So we're taking all the weights and just think about, again, these connections in your body, your brain, and these neurons and the paths that really light up and fire. And we're overlaying that on top of the images. And we can see, where it got the answer right and perhaps why. And then in the case of where it didn't, you can see also that. But it's a research area, and it's part of what I'm excited trying to do and working with the team on actively. And DARPA, those guys are pretty sharp too, and I'm sure they're coming up with good work. There's something called LIME too. That's a model agnostic method. I'm not particularly bullish on it, but it's out there as well, LIME.
Mm-hmm. Great. So just to wrap up, I've got to ask you about the known unknowns that we're going to run into in cognitive computing, which is to say, what kinds of surprises do you think might be coming down the road in the next few years as these technologies get adopted more and more, and people who are working in AI try to deliver value that sort of lives up to the hype that the AI is getting at the moment?
Well, I think we take some things for granted, even like a spell checker in the past. That was a form of AI that we just take for granted now, and it really helped you and assists you, and even now looks at grammatical structure and so forth as you're writing a blog, let's say, and goodness knows I need help with that. But I think I think that there is some fear and uncertainty, that about, well, is this going to take my job, or am I going to be, is the machine really going to replace what I do? And I don't think it'll necessarily replace data scientists. My team, they're pretty good modelers, and it's going to allow them to work on some of the more difficult problems, because I don't think the machine can truly reason right now. I mean, it doesn't understand emotion, it doesn't understand feeling like you do, doesn't have all the senses incorporated into it. But I think some things, like, transportation and so forth, there are fields like that, manufacturing processes with robotics, your job could likely be gone.
Well, stay tuned, I guess, is the
Yeah, exactly.
byword there. But
again,
okay.
I really recommend, the last thing I'll say is we not to worry about the terminology and getting that exactly right. I have watched that internally at SAS. I was at a customer advisory board, and so I started off my presentation. I bought some index cards, and I passed them out to all the attendees. And these are people on a customer advisory board that help, advise where our software is going. And I couldn't believe how well the definitions were. And so I'm seeing out there, people are understanding what it's about, and let's not get bogged down in the specifics. And I've seen that internally here at SAS even, and it doesn't concern me.
Great. Well, hopefully the mainstream press will pick up your attitude and stop confusing business folks and people who are, losing sleep over losing their job, for example. But okay, so Hannah, maybe we should wrap up.
Yeah, absolutely. So thank you so much, Wayne, again, for your time today and your thoughtful presentation. For all the attendees, just so you know, the slides as well as the recording of today's webinar will be available on our website, likely later today, latest later tomorrow. So please be sure to check there. And we hope that all of you can join for next month's webinar. We'll be sending the information out on that probably in the next week or so. So thank you all, and have a great rest of your day.
Thank you. Bye-bye.
Bye.